Good morning, Year 9. So today we're looking at finding the equation of a direct proportion that's given in table form. One of the first things to notice here is that in a table we've got the top row, which in this case is x, and generally it will be, and the bottom row, which generally is y, though we can use other variables here as well. The x values are the values that we feed into the equation basically, and they will be on the right hand side of the equation. So we'll always have an equation y is equal to something which we call k times x. That's what we're going to end up getting. So notice that x always is on the right hand side of the equal sign, and the bottom one, whether it's y or b or c or whatever it is, the bottom one goes on the left hand side of the equation. Now what we actually need to find out is what is the value of this number that we're timesing the top row with to get the bottom row every time. And it should be fairly clear in this case that if we times 1 with 2, we're going to get 2. If we times 3 with 2, we're going to get 6. 6 by 2 is 12, and 8 times 2 is 16. The way we could show that mathematically is simply dividing each bottom value by each top value and showing that we get the same answer. Like 2 divided by 1 we know is 2, that's the same as 6 divided by 3, which is also 2, same as 12 divided by 6, which is also 2, same as 16 divided by 8, which is all equal to 2. Therefore we know that the equation is, we start with the bottom variable, which is y, so y is equal to k times x. And now the value of k, the number before x there, is this 2. So it becomes 2 times x. And there's your formula. All right, I've added one extra example here that's not in the textbook, which is also more just for the people that do option 1 and everyone. So going on from B, it's more for the people that do option 2 and 3. But this A2, I still want everyone to get very clearly, please. Okay, so the first thing we need to do here is figure out what is the value of k. Now in this case, it's not x and y. We start with the bottom variable, and our equation will be r is equal to k times, and then the top variable, which is in this case p. So what we're going to do here to find the value of k is we will divide the bottom one by the top one. So in other words, r divided by p. Now there's only 2 complete sets of values for r and p, which is there and there. So let's go and see, always bottom divided by top. What is 1 divided by 4? That's a quarter, right? And what about 7 divided by 28? You can go and look on your calculators, or we could simply say, well, 7 is a common factor here, so I can divide top and bottom by 7, which once again give me equal to 1 over 4. So the value of k in this case is a quarter. I times the top one with a quarter to get the bottom one. So that's k. In other words, we could say that r is equal to a quarter of p. Now in this case, there were also some values left out that we need to find. Yeah, this value is not given, this value up here is not given, and this value also is not given. So we need to figure them out. So going from p to r, we times by a quarter. So we go a quarter times 12 times a quarter. And that, if you use your calculator, you will see that that's equal to 3. So this value is 3. If we go from the bottom row to the top row, then we're going to divide by this value, the value of k, because we're going basically the other way around, or the wrong way around. So here we'll go 12 divided by a quarter. You can once again use your calculator and you'll get the value 48. So this one there is 48. And for the last one, it is the right way around, again from top to bottom. So we're just going to times by a quarter, 200 times a quarter, which of course is equal to 50. So that value is 50. Cool. All right, so everyone can keep on watching, but the next two problems are mostly for those people that do option 2 and option 3 of the homework. So if you look at B, it's a bit interesting because if we focus on this values here, which is nice to work because 1 times k will give us the value. So 1 times what gives us 2, or 2 divided by 1, that's obviously 2. But it doesn't work for the next one because 2 times 2 is 4 and 3 times 2 is only 6. So you can see as we go bigger, it gets further and further out from what the required result is. Now what we can do, if we get the values that we get are too small, we can try squaring or cubing the top value. So let's look at that. If I go and square each of the top values, so that's just something I can try. And this will result in a new table. So let's look at the new table. Is an s squared and t. 0 times itself is still 0, 1 times itself is still 1, 2 times itself is 4, 3 times itself, 3 squared is 9, and 5 times itself is 25. The bottom value stays the same, 0, 2, 8, 18, 50. Is there a constant ratio now? Yep. If we times s squared by 2, we every time get the bottom. So if I go and look at 2 divided by 1, that's the same as 8 divided by 4, which is the same as 18 divided by 9, also the same as 50 divided by 25, which means we do have a direct proportion here with k equal to 2. But in this case, it's not t equal to 2s, it is t equal to 2s squared, because we had to go and square the top variable for this to work. Right, last one. If we go and look at the 1 value again, which is always a good one, I have to times the 1 by 3 to get the bottom value of 3. But if I times 4 by 3, you get 12. So in this case, the answers we get are too big. If I times 9 by 3, I get 27. So it's way too big. So now in this case, I need to make the top value smaller rather than bigger. And what we can try, if that's the case, is we can try square rooting. So I'm going to square root each of these values. And let's see what the new table would be then. So that gives me a square root of a and b. Square root of 0, you can do this on your calculator if you don't know how to, but it's 0. Square root of 1 is 1. Square root of 4, which number times itself gives 4, that's 2. Which number times itself gives 9, that's 3. And the bottom values once again stays the same. Is there a constant ratio now? What is 3 divided by 1? That's 3. What about 6 divided by 2? That's also 3. And 9 divided by 3 is also 3. So k is equal to 3, but once again, it's not simply b is equal to 3k, or 3a. It is b is equal to 3 times the square root of a, because it only worked once we square rooted a. And that's it. Enjoy the homework. Cheers.